Good morning, everyone. Today we'll look into one design pattern, strategy design pattern. Strategy design pattern states that we have a group of algorithms. We can select one algorithm based on the requirement that can interchangeable without any conditions. Like we'll look into that strategy design pattern in some time. For example, suppose we have an zoo. In that zoo, we have different animals. For that, I have taken an animal as an interface. For this animal have walk and sound, I have two methods. I have implemented this animal in the two classes like dog and elephant. These two animals I have implemented. Currently, I have these animals in the zoo. When I run this, it will print that sound. I can make sound and walk. These two. Suppose I have another requirement like in the zoo we have added different animals. For that animals they have another quality like climb, but the climb will not be relevant to this elephant. If he added that climb method in this animal, we have to implement for this all the implemented classes like here dog and elephant. For the elephant, that climb method doesn't have any sense to implement. We need to provide the default implementation, or we need to give the some dummy implementation. Instead of doing that, can we have that climb method is defined in another interface? What are the interfaces? What are the animals we have is is applicable for that animals only we can implement. That is a good way, right? For that, what I'm doing is I'm creating one interface as a climb. For that, I have a method like climb. This dog can climb some trees on walls, right? But elephant cannot. I can do that for the dog. I can make this. I can implement this interface to the dog because it can climb some low level or some trees and walls. Okay, here what I am doing is I am making as this for the dog only. I am implementing this class. I can climb. Okay, and when I run this in this two method, I can call this for this dog. Okay, dog dot climb. Okay. If you run this for the dog, we can make it as climb, and the elephant cannot climb. Right? This one is dog. Dog has can climb, and elephant cannot climb. We are not implementing the interface. Okay. Suppose if we the dog is good condition, it can climb the stair. Suppose if the dog has some uh, it will not climb for some reasons. Okay, then what we need to do? We need to go to the dog class and we need to implement this method. We need to change already implemented change. We need to change this one to some I cannot climb because of some reasons. Okay, for this I cannot claim. For this, what we are doing is we are changing the existing class. Already this class is running and it is behaving same. And like this, we have if one or two classes is a climb is there that we are implementing, we are changing. Now, if we go to this and if we run this, here we'll see that dog cannot I cannot climb. Okay, like this. If we are changing this implementations based on the situations, based on the time or strategy. Okay, can we have a better option instead of going to the implementation classes and doing the changes? Is there any way we can dynamically change the behavior of this dog without touching the dog class? Like with the minimal changes, not without touching, but with minimal changes. Yes, we have a way. Here, here we are doing the inheritance. Instead of doing the inheritance, we can go for the composition. What is the composition is? The class is an has a relationship. The dog has a climb interface. Yes, dog has a climb interface. Okay. We have created an interface in the as a variable in the dog class and use that instead of providing this implementation for this method, we are depending on the variable, and we are calling that method. What are the interface we have created for the client we have created for the interface, right? This interface we are giving this here for the climb method. We are not giving the direct implementation. We are depending on the variable to give the implementation. I have implemented this interface. I have implemented this interface two implementations. One is climbers. Yes, climbers. Climbers. Yes, I can climb, and non-climbers. No, I cannot. Okay. For that, what we need to do is we need to inject this climb different implementations. For that, what we need to create a setters and getters for this. We need to create setters and getters for the climb. Okay, I need to create setters and getters, and we can insert this different implementations on the runtime based on the implementation class. This will be running. Okay, now we have go to this. Here we are getting some error like here override is not required because we have removed the interface, right? Okay, now I have injected this one using the setter methods, and when I go to the Jew class, and for the dog we have to give the we have to set the climb interface, right? We have to set the climb interface. For the climb interface, I have two interfaces, two implementation classes like non-climbers, because now our situation is the dog cannot climb, right? Now I am providing this non-climbers as the parameter to the dog. I can set climb is equal to climb. Okay, now when I call this climb, it will call the non-climbers, and in the non-climbers class, what is the implementation is there in a non-climber class? Sorry, I cannot, because in our situation, currently our situation, dog cannot able to climb this one, right? I can do. If I run this code, it will, sorry, I cannot. Dog saying that, sorry, I cannot. Suppose in some situations, I dog can climb after some days. Okay, then I want to change the behavior from non-climbers to climbers. Then instead of changing the dog class in the dog class, I can change the client class, and I can insert that climbers as a object to the dog, and the climbers will call this one climbers. Yes, I can. Now if we run this code, it will show that output as I can climb. Okay, climbers, yeah, I can. This way we can in we have a different behaviors. Okay, based on our situation, we can change the behaviors dynamically using the strategy design pattern. Here, what we are using is this is the dog. In the dog, we are using one variables like climb. This is of type climb. This type is called interface. If we are using interface like programming to the interface, then we have a facility to modify this one, modify dynamically. But if we hard coded this here like implementation classes like climbers, we cannot send this climbers to this non-climbers because implementation classes is different. Here we are following the one design principle, programming to an interface. Okay, this is a programming to an interface, and here we are implementing animal class because this animals is the same for all type of animals. Walk and sound is the mandatory or not mandatory, some common methods. Okay, for that we are using inheritance. The behaviors which are changing, for that behaviors, instead of using inheritance, what we are using is a composition. Here the composition, we are inserting an object as a variable to the class. This is called composition. In this, and for every animal, for every animal, the climb behavior is different, right? For that, what we are using is, instead of adding this behavior in the already existing interface, we have created another interface, and for this interface we are giving implementations and using that one. In this way, we are not disturbing the existing functionality. And what are the functionality, new functionality are adding dynamically? Okay, this is encapsulating what varies. What are the suppose this is the one design principle is encapsulating what varies. This is varies from animal to animal. This one is created as a new interface and creating as one class, and depending on the situations we are adding to the view class. This way, this is the practical example of the strategy design pattern. Okay, thank you very much. If you have any comments, please post in the comments. Thank you.